For my video project, I will be talking about continental drift. So, continental drift is one of the earliest ways that geologists believed continents moved over time, and today this has been replaced by the science of plate tectonics, which holds many of the same assumptions about how the continents got to where they are today. Continental drift theory was first codified by Alfred Wegener in the early 20th century when he published a paper first explaining that the continental land masses were drifting across Earth's crust. His theory also said that the continents were at one time joined together as a single supercontinent, which he named Pangaea, and this name means all Earth in ancient Greek. Wegener was the first scientist to even believe that the continents could move, and alongside some other scientists who supported his theory, Wegener put together a good amount of evidence for the continental drift theory. And that on the right is a photo of his conception of Pangaea. The first and one of the most major pieces of evidence is that identical rocks of the same type and age can be found on both sides of the Atlantic Ocean, and if you piece the continents together, these areas line up extremely well. So this is clear evidence towards the breaking of this land and separation into continents. And one specific example that you can see in the left image is the Appalachians and some mountain ranges in eastern Greenland, Ireland, Great Britain, and Norway, which Wegener concluded were formed as a single mountain range at one point before they were separated. So you can see in the image, the red areas are where those mountain ranges are, and they include similar, almost identical rock types that if you line up, there's evidence that they were once the same mountain range. And then another clear indication that's shown in the image on the right is in comparing the east coast of South America and the west coast of Africa, which also line up extremely well. Another significant piece of evidence for continental drift is the existence of ancient fossils of the same species of extinct plants and animals that are found in rocks on different continents. So Wegener observed that these species most likely had lived in the same area before the splitting of the continents, and the land had moved apart after they were fossilized. To support this, he also observed that these species would not have been able to make it across an ocean, so them existing in the same area at one point is the only reasonable explanation for their current existence on different continents. One fossil found in southern Africa and South America was the Mesosaurus, which is a freshwater reptile only 1 meter long that could not have swam the Atlantic Ocean to travel from one continent to the other. So the existence of Mesosaurus fossils in these two areas suggests a single habitat they once lived in that has now separated into different continents. And in this image, you can see a number of different examples of fossils that are found on different continents. The Mesosaurus specifically is down in the bottom left. So that was the second piece of evidence. And with this evidence and other technology, geologists have been able to date the existence of Pangaea back about 240 million years ago, also deducing that by about 200 million years ago, this supercontinent started to separate. Scientists also believe that several supercontinents like Pangaea have existed and broken up throughout Earth's lifespan. While Wegener's work was not widely accepted at the time, it is now the basis for what we understand about plate tectonics and how the continents actually moved over those hundreds of millions of years. And those are my sources. Thank you.